Hey, hey. Hello, welcome back to the stream. So, I'm back from the party. It's 15 to 1 here. But I still have some strength to continue with just getting this. Oh, what is this? Chat mod icons explore shield mode. I don't know what this shield mode is. Anyway, yeah, I still have a little bit of strength to. I really want to see that test cube glTF loaded in the game. So yeah, let me just share the stuff and begin. Hello, two-step. Back for more. That's you doing that. You're the one that has a pull request, right? I just saw it and I was like, oh, what is... I could have easily missed it, but I saw like, oh, wait, there is a message in my GitHub. Yeah, that's me. Good. Yeah. Let's see. Oh yeah, I should also say it in the Zig maybe. Okay, I shared everything. Time to focus. Okay, let me turn on the chat. Okay, there it is. I went back and skimmed through the beginning of today's earlier VOD. Looks like you were pretty close then. Yeah. Yeah, let me get into the stuff. Okay, well, hello. Hello, everybody. Here is beginning of the stream. This is the 9th stream. I didn't prepare anything because I just got home and I was like, okay, I just wanna stream this, get that test cube to show in the game. Okay, so yes, this is basically the continuation of my stream that I got to. I said add glTF loading, but I didn't manage to get this Zig friendly model. The package manager is still pretty undocumented. Yeah, I see that. I think things are going to improve with the package. I mean, it's the fresh new technology in Zig, so we will see it get better. Okay, so on this stream, I'm basically doing this, right? I need to, well, not just load textures, but load objects, well, load objects. For the beginning, I want to show load a mesh with vertices and indices. Okay, and then load multiple objects, and then finally I want to load some textures as well, and then finally hopefully abstract. But first off, this is what happened in between. So two-step here from the stream, he filed a pull request, and I just noticed it when I came home. I was like, what is this? Attempt to use co-parse glTF. So if you have watched my previous stream today, I had problems installing, oh, this is my C++ engine. I had problems installing the, what was it? This one, zglTF from co-parse. And then because I didn't know how to actually include it into the module, as a module into my engine, because it doesn't have any like, oh yeah, what confused me was that it has this .module function, but it didn't work. It was not in the latest commit. It has it in the documentation, but not in the commit. So I wasn't sure how to use it. And then instead, I decided to use cglTF directly. So this is the C version of glTF. And then I decided to import it through this zcglTF, which is like a thin wrapper over cglTF. And this one is from Jock, the other game engine. And yeah, and in the meantime, while I was partying, two-step here, managed to got co-parses zglTF working, and it is so what are the actual differences? This is an unfinished attempt to parse test cube glTF using zglTF. I've been able to add a zglTF module and pass the glTF with it, but I'm not sure how to parse the vertices. Maybe you can figure out if you think it is preferable to using zglTF directly. I've added a bool use zglTF. Okay, and here is what you will see if you run. Great, cool. And there's just some statistics of the file. So what is actually the difference? Well, the difference here is that this is how you add a module, and I had no idea. So you can add a module as a B dependency, build.dependency, and then you just need to pass it the target and optimize. Isn't that actually the similar way how I'm doing the other stuff? Yeah, this is exactly how Mach works, but I didn't realize this myself. Yeah, Mach dependency, and then you add Mach. Oh yeah, but Mach has its own thing. It actually imports yeah, it has this module thing, which you can pass it as a builder and optimize targets. Yeah. Is the Mach dependency even necessary? I guess it is. Yeah, anyway. Okay, so the only thing I had to do here was to do a, yeah, basically like this, B dependency instead of B create module. Yeah, create module is when you have a single file, I guess. Like I'm using from GL, and which is actually in the path locally. But yeah, since this is not local, then you need to create it as a dependency. Okay, yes. And then, yeah, of course, it's good that I commented this. Yeah, so he uncommented that, and this is glTF. and then also just added this one. So yeah, this is now an if not, this is my thing, and then this is the new. Yeah, definitely much nicer with nested for loops. But then, yeah, then there is stuff. Debug print, interesting. It has its own debug print, nice. Okay, let me merge this pull request, and then we will continue working on the zglTF implementation. Okay, confirm. Yeah, and by the way, I just said starting a new stream right now to merge this, and it was half an hour ago. For sure, pretty close. Just missing a B dependency. Yeah. Okay. Cool. Let's fetch everything. There it is. Merged pull request. Here we go. Okay. So, by the way, what are you saying? I was also curious about Specs Guy's glTF lib that you look at. He's a Zig core team member, so I'm hopeful that it might be pretty good. Okay. I think Mach is weird for now due to working around some package manager issues. Yeah, maybe. Yeah, I have to admit I don't fully understand packages and modules. I'm just like, if you can give me, if I can copy this code into my build, that would be great. I do understand how C compilation now works, thankfully, but the modules themselves are a bit confusing. Okay, so yeah, I'm hopefully going to be able to kick this one out, the cglTF. But for now, let's. Oh, sorry, my light is disappearing. I have to knock the lamp a bit for it to get on, to turn on. Okay, so what is going on here? Let's go back into main and let's see what's going on here. Here it is, nested for loops. Beautiful. Okay, so yes, vertices are an F32 array list in this case. That's fine, but let's see. Accessor. Okay, so we have an accessor, and this is what I like. Like the attribute is actually dot position. It's not like a string that I have to match, which is nice. Let's see. Oh, no definition. Again, ZLS is not giving me this. Where is oh yeah, zglTF is in the package. Oh well. Does glTF obj data accessors? Why doesn't it give me zglTF? What's the type? It doesn't give me a type. Okay, so ZLS doesn't work on this one. All right. Well, actually, let me build first. Maybe that's why. Yeah, probably that's why, because I haven't built. So let's see what happens. B dependency is the standard way to use debs from a zone file. I see. Okay, good to know. All right, so here we go. This is the exact problem, info to do get data. The good thing is that the game works. Okay, does ZLS now work? Not yet. Let's try to restart. Maybe it will figure itself out. Okay, I have my engine just for a checkup. Let's do another instance. Aha, loading. It's loading. It's loading. Let's hope it works. There it is. Nice. Oh, is it working? There it is. Cool. Okay, good. We can jump to it. This is very, very useful. Okay, so accessor. Yeah, we now have there it is. Items. Oh, cool. It even has some. It even has some. How do you call it? Documentation about it. Okay, found position. So yeah, dot position. Yeah, we can also now. Oh, we can't, but we can jump to the attribute. Can we jump to this one? Oh, no data. Okay, well, at least some of them work. The good thing is that this is a slice, so we can just for through it. Okay, so attribute position, that's the accessor. Okay, and then what did we do here? So attribute has the data, hopefully. Get data from buffer view. Interesting. What is this? Oh, why doesn't it? Why can't I? Okay, let's go here. Get data from buffer view. Retrieve actual data from a glTF buffer view through a given glTF accessor. This library won't pull the memory, the binary buffer corresponding to the buffer view. List that will be filled with data. So yeah, you mentioned something about binary. Get data. The following is from the example on the glTF readme. Not sure if it would work. I tried passing glTF source for the bin parameter below, but this isn't correct. Bin seems to expect some kind of binary file. Well, yeah, glTF comes in a GLB version, which is also a binary file. But in this case, I don't have a binary. But maybe, I don't know if this is only for binary or get data from buffer view. It doesn't actually show. Oh, well. What's the signature? Takes in a type. List that is going to be filled. Accessor binary. Okay, so you can't pass a null because it takes in a slice. But maybe the binary is actually the buffer. No? I don't understand the binary. This library won't pull the memory, the binary buffer corresponding to the buffer view. Pull the memory. What? This library won't pull to memory the binary buffer. Yeah, I am a little bit confused about this. GLB is basically the JSON plus binary packed in glTF. Because JSON is one file. Binary is possibly multiple other files. ZLS worked fine for me. Maybe try to build it first. Yeah, I built it. Okay. So let's see. What did I do here? I found the buffer through a buffer view. Can I actually do something similar, where the accessor was actually stored inside? Yeah, there was a buffer view inside the accessor, you know. Okay, can I go to accessor? Yes. Buffer view is an index in this case. The index of the buffer view. And an index is a usize. Yeah. So in this case, well, in the ZCL, what's the name of it? ZC, in the C version, there was actually a way to, it was actually giving us a pointer and not an index, but this is an index. So basically what we need to do is, because it's an index, okay, buffer view index, no, let's use it purely. The thing is that we need to get all the buffer views, ZGL zglTF buffer view. Okay. But that's probably what this is doing. That's probably what this is doing, no? Get data from get data from buffer view. Ah, it's case sensitive. Whoops. Get data from buffer view. Where is it? Why doesn't it work? This is types zig. Why am I in types zig? Why is it now unknown? Okay. Okay, that was actually in the... Yeah, this doesn't work. Okay, accessor. Types. It is in types, after all. But it's not actually in types. It is, it's somewhere else. Source. Main. There it is. Okay, retrieve actual data from a glTF buffer view through a given glTF accessor. So what does it do? Mismatch between glTF components. Okay, there are different types. I get that. Buffer view. Accessor count. Okay. What about the vec3? Okay. So what is this pointer? I guess this is a pointer into the buffer. No? Probably. Because this is how it decodes the data. And it has a stride as well. So I don't think this is actually what I need, because this fills a list. This fills a list with and I think this is going to be completely how do I say, compressed, like compacted. I need to interleave the data. Current count use size. Because it goes through and then strides. What the hell is a datum count? Bin results from embedding a bin file. Oh. Wait, there was supposed to be a period after in. GLB is basically the JSON binary packed in. glTF is JSON is one file, binary as possible, multiple other files. I understand some of those lines of code. It's not a method of attributes. If you look at the README, bin results from embedding a bin file. Okay, so maybe that's not what I need. But yeah, I would actually like to just walk through the data, just like I did here. So let's get the buffer manually. Okay. Let's get the buffer manually, if I can. So I need to find that data. I have the accessor. I have the buffer view. No? Okay. So from the accessor count, accessor buffer view. I actually got the accessor from the buffer view, not from the attribute. Okay. Let's go to the attributes. Let's find the attributes type. Okay, it doesn't have. Okay, it doesn't help me. Okay, so that's wrong. It doesn't have a buffer view. So it's in the accessor buffer view. There it is, which is an index. Yeah, I already tried that. So this is a buffer view index. I'm gonna unpack it, and I'm gonna use that to fetch the buffer view from the entire node, hopefully. Can you mesh primitive? Okay. That is how I did it in my C++ code, if I remember correctly. Because the attributes, there it is. Buffer is in the models, actually. Buffer view, buffer. Oh, buffer view, buffer. But how do I get the buffer? I get it from the buffer view, I guess. But I need to index it. Okay, so is a model, no, what's the name of it? glTF, that's the object. Maybe, no, it's not. Data, it's data. Okay, that's the model. Data, buffer views, and then I can take the BVI. Okay, and then hopefully that returns me the buffer view. Okay, it returns me the buffer view, and I can get a buffer index. Okay, and then I can get all the buffers and get the buffer, hopefully. Okay, so if I go to the buffer, there it is. It should give me a buffer, which gives me relative buffer relative to current shield. It could contain the data. Isn't implemented. Data URI is not implemented in this library. So hopefully this is not null. Let's call it buffer optional. And then capture the buffer. And then see if log info buffer exists. Let's see what the buffer index is, and buffer view index as well. Okay. Is this an optional? It's not an optional. Data buffers. Okay. The way I check this is that I need to, I guess. Okay, what's my data? No, it's not an optional. It's a buffer. Okay, sorry. This is game engine GUI. Wait. It's not a method of, if you look at the README. This is a good infographic to have around when working on glTF. Seems like maybe it would be better to go back to the old way. Access or buffer view indexes into buffer views, and then buffer view buffer indexes into buffers. Yeah, I know that. That's why. That's exactly what I'm doing. URI means uniform resource identifier, and locally, that's going to mean a file name of the binary. On the web, it's going to be something like a URL. Ah, I see. Yeah, that's what I do to download stuff from the internet, buffers. But in my case, yeah, this is going to hopefully be correct. So yeah, I don't need actually this, because if buffer exists, it will, it should throw an error if this is incorrect. So let's see if this even builds, or it throws an error. Okay, there is a problem here. Type array list aligned does not support indexing. Operand must be an array. Okay, let's see. Why does it not support array list? Oh, these are all array lists. So I need items buffer. Oh, sorry, in this one. Items BVI, and this is also going to be items, because everything is an array list. Okay, there it is. It seems to be working. Okay, let's log the first item of the buffer. First item. It should be -3 or something, right? But what is it actually? Is it, if I remember correctly, the buffer? Oh, not that. The buffers. Array list of buffer, the data. This is the data, no? Wait a minute, what the hell? What am I doing in my... Okay, I have a buffer. Model buffers, okay, and my buffer is what? My buffer has the data. My buffer contains data directly. But in this case, they have a URI. Relative paths are relative. Okay, it could contain data URI instead of a path. So is it data or not? It's not data. What the hell? Okay. Just give me the data. So yeah, the buffer view actually gives you all the data about how big is the items and everything, but it should also give you a buffer, and this one has a URI. Okay, let's see what the URI is. What is the URI? Let's also output the length. And this is a const8, so maybe it's a string. Let's output as a string, and it's an optional string as well. Buffer the length. Oh, there's 2 of those. What are you looking for? I'm looking for my data, the actual payload of the buffer. There it is. It's gonna throw me an error. Oh, it's broken. It's broken. Something is happening. What is happening? Not responding. Okay, this is weird. This is a freeze. It's not a crash. How? And my VS Code is also broken now. I think something really bad is going on. Building. It's stuck in building. And it's totally broken. Maybe you can't even see me streaming anymore. No. What the fuck, the coincidence? I was here the other day. Wait, what? Oh no, it's oh no. That looks like a path buffer, but path to what? I mean, it's not anywhere else. There it is. It's okay. It's just broke. Just broke completely. I wonder what happened. Is it because I'm trying to unpack? But no, it should throw an error. Okay, let's try again. Let's try again. Maybe it was something weird. No. It's also fucked. This shouldn't happen. How is this even happening? How is this even possible? Is it like is it trying to read an infinite array or something? And now it's stuck again, and it's gonna crash. I'm thinking of trying the specs guys lib binding. Maybe take a look at it and let me know if you think it would be worthwhile. Maybe. Oh. Okay, it's you. Sorry, Tubbs made your program crash. Yeah, this raid made my made this crash. Yeah, maybe I should go back to the old ways, to the cglTF. You got raided. You're being raided. Yeah, great. Okay, cool. We have another crash. So yeah, definitely not. Definitely, maybe I should not try this one. I don't know what the hell is going on there. Because it's probably because of this of the info. Maybe I'm trying to log a infinite. But no, this is definitely bounded, right? Okay, maybe I'm just trying to unpack this. But no, it should still throw an error if it's a null. Let's actually output this. Let's do a URI, and then I'm gonna just output the length of the URI. Let's see if this is totally broken. Okay, one more attempt. Are you aware that you have 70 viewers here? Yeah, I see now. Yeah, I am aware. What collection is okay? There is. Let's see what's going on. Oh, look, there's an error now. Nice. And it says invalid format string. Okay, yeah, invalid format string. This is a compilation error. We will talk about this tomorrow. We are zigged because of you. You're an infinite array chat. Yeah, exactly. Oh. Pack another memory stick in. Okay, so this works. Let's see. Oh, look at that. Look at that. It has 32. It has 328,000 characters. Yeah. That's an interesting URI. It was trying to probably print this. It was trying to print this string maybe. And then it completely failed. That was probably the problem. But interestingly, yeah, so this can't be the data as well, because the data can't be this big. And the length is really weird. Okay, I am really confused about what's going on here. What the hell is going on with the buffer? Yeah, I'm thinking that something here is not initialized. Something here is not initialized. I'm pretty sure. And then it's giving me gibberish values. Why don't you turn on some music when you work? Yeah, I don't want to be like taken down for copyright. Maya brought peace to my nights, but now I need to recharge. Okay, please no music. Yeah. I mean, look, if you want some music, put on some music yourself. Okay. Look, I'm gonna go back. I really want to see this my cube rendering. So I'm gonna go back to the old ways with cglTF. So let's just put a false here. And now hopefully we're gonna be back on this one. So yeah, no luck with the new thing. I just want to display this one cube. Rebuilding. By the way, I think this const use glTF is not compile time. You need to put the comp time here. Because this is in the function. I figured out what's the difference between comp time and not comp time. So if you want, oh, what's happening? It's still building. It's still building. Ah, it's because I'm already running it. Okay. It's a wrong message. So yeah, there it is. We have the vertices. Anyway, look, I figured out what the difference is between comp time and not comp time. If you are in a outside and you say, you know, use glTF, whatever, use flags, whatever that means, and then you say true, right? This is going to be true forever, and at compile time. So if you put comp time here, it's going to say unnecessary comp time, redundant comp time, because this is already comp time. But if you're in a function and you say const something is false, then this is not comp time actually. This will be assigned the value of false once you get into the function. And if you really want to make it comp time, you have to make it comp time. And this is not used, so that's why it gives me. But yeah, so just a little thing. It's very similar to using const expr in C++. So yeah, this means that if this is a comp time false, then it will completely remove this code. That's the main difference. It's almost like using a macro in C and C++. If I said if def use the glTF. Anyway, maybe move on. We can open an issue. Yeah, let's just see. Use pretzel for copyright-free music. Okay, nice. Have fun. Me going to crash myself. See ya. See ya. Yeah, I'm gonna move on. So, let me see what's going on. Let me see what's going on here. Quick question, Notke. Okay, somebody wants me to do something about... Did you get a chance to read my previous email? Oh, whoops, I don't think I did. Okay. So, two step says, that's not necessarily the case. I agree that at file container scope, it's automatically comp time, but in other scope, const x of false is also comp time. No, yeah, probably, but it's like this is a way to make sure. Yeah, I'm pretty sure that in release mode at least, it's going to, it's going to remove it if you put it as a constant. 350k is too big for a stack allocation. Print alloc, parse alloc. How do you like Zig so far? I really like it. I do miss a little bit of C++, like fire and forget stuff, because in C++ there's a lot of magical stuff like, std string, and you just say std string and whatever, and you can just, it's kind of like fire and forget, and you don't really think about it. Here, if you want to do something, dynamic like this, you would need to pass in an allocator because string is not a thing. You would need to have a list of stuff. And also, I mean, std vector is also very magical in C++. But yeah, it does give you an ability to pass in an allocator. But in Zig, it's very like allocator first. So it doesn't allow you to not pass an allocator, kind of. But yeah, everything, I think that's the only thing like I maybe miss a few of those fire and forget things, as I would call them. But otherwise, there's actually a lot of good things. Everything else is great because first, there's no header files. Amazing. Yeah, I don't spend any time flipping between the declarations and definitions. Oh my god, that's just hurts my brain. I don't have to think about how my whole compilation thing is composed. If I put this above this, it's going to be completely different in C++. When I'm importing stuff like and stuff like that. If I'm going to have some kind of an accidental shadowing, or there's going to be a conflict between values, because everything is scoped in Zig, and you can alias basically anything with the const from another file. And yeah, it's just, I don't know, it just looks so nicer. It's very nice to have a built-in build system. I just love how you can just get you can get any library from GitHub, and you can just say zig build run, and that's it. And then there's a lot of cool stuff like built-in slices, optionals, errors, and stuff like that. C++ 20 has modules to solve headers. Oh yeah, right. But it's very early. I tried to use modules and I couldn't get it to work with Visual Studio, and I don't know. It's terrible support. But yeah, modules are a way to go forward, but it will take some time to get them working correctly. I mean, they actually worked. They actually worked with Visual Studio, but I couldn't get IntelliSense to work. So IntelliSense didn't want to accept the modules. That was the problem. Last time I tried. No hidden allocations as with std string. Line. Try glTF parse. Test cube should allocate. You mean this one? Oh yeah, well, no. If you mean this one, I don't know which one you mean. 350. Can't put it on the stack. But this is using a GPA allocator, so it's not the stack. This is using the GPA that I defined on the start. So that's not on stack. That's on the heap. I don't think that's the problem. There is nothing on the stack here. And by the way, if there was a Stack Overflow, I'm pretty sure it would panic. Would it? That bit of the code was working before, as you're saying. Parse would be... No, there's something wrong here. There's something wrong here because the buffer is gibberish. The length the length and the byte length, but it shouldn't be. That's the thing, because okay, you know what I'm trying to load? You know what I'm trying to load? I'm trying to load this. Okay, I'm trying to load the test cube. And test cube has literally like, there it is. It has like 10 vertices or whatever. Actually, I just ran the working code. Here it is. This is the working code. And you can see that, wait a minute. Is it true? It has so many vertices. Okay, I think it has so many vertices because it's all it's using normals. So every vertex is split. But it's impossible because each of these is just a number, right? There is size of vertex. I think it's 64. That's it. It's 64 vertices times 3 times 4. That's not 500,000. So even if it was bytes, it's impossible. No, I think this is something. The problem is different. I probably should be using this get data from buffer_u or something, but it's taking a binary. I don't know. I'm not sure how it works. If somebody wants to look at it, well, it's there. It's parse glTF. Oh, not search Bing. Yuck. There it is. This is the guy's front page. Looks nice. Yeah, and there it is. So it has an example. What's a bin? Try read file alloc. What is this bin thing? This is something weird. I don't have a binary. Everything is embedded. Yeah, I think that the problem is that it doesn't understand that things can be embedded and not outside. Maybe it's just linking an outside file. I think maybe people are confused because there is working code above, which is similar to non-working code. Yeah, that's true. They don't understand the history because this is my first implementation. And then two-step here, try to help me with this implementation. But the library is not that good. So I'm just going to go with cglTF. Okay, let's can I collapse this? No, I can't. Okay, VS Code doesn't understand that this is collapsible. Cool. Okay, let's not look at this. Okay, I'm gonna look at this. So this one is the C implementation, and this one, unfortunately, does mallocs. So this one has hidden allocations, but at least it works, right? I'm not passing an allocator into this one because this is all implemented in C. But at least it works. I got the buffer. I got vertices like here extracted from the file. So yeah, let's go with that. Okay, I found the position. That's where I forgot. That's where I forgot. That's where I stopped. And then for each of the vertex counts, I am actually casting it into, this is very verbose. Basically, I'm casting the data into the vector 3. Okay. And then what I can do is I can append vertices. And then instead of this, for each of the primitives, yeah, there is only one primitive actually. For each attribute, right, this is for each attribute. For each attribute. Okay, so now I have to catch another one, which is, oh no. What I need to do is I need to find indices. And how do I do this? Where are my indices? Indices. Component type. Ah, there it is. No, this is unsigned short. This is float color. Let's find, where are my indices? Indices. Oh, it's a completely different thing. It's not an accessor, is it? Okay, it's completely outside of attributes. It's actually an index accessor, model accessors. Okay, so it's outside of this. It's part of the primitive. But it's not an attribute. Yeah, that makes sense. So let's see. We were testing out a lib. Okay, yeah, that's information for people who don't know what's going on. So let's see. What I'm doing is I'm getting this from model accessors. Okay. I am using this somewhere, right? No, I'm not. Okay, I am getting an accessors from... I'm getting the accessor from data. Is there a better way to get this index accessor? Primitive indices. Oh no, it's primitive indices. Does it have it? Primitive attributes. Okay. I want this. Parse file. Okay. Let's find accessor. Accessor indices. There are no indices. No, it's actually a primitive that I need. A primitive, there it is. It does have indices. And it's actually a pointer to the accessor. Okay. And it's also an optional pointer. And indices, is it... oh yeah, indices... Oh, this is what I want. And then, inside the accessor, I can get the buffer view. As I did. Okay, let's put a... It should probably be a const. Index accessor. Oh, wrong thing. Okay, the index accessor, that's what I'm doing here. And then I get the buffer view. Yeah. Okay, so index accessor buffer view. And then I can unpack that and take the buffer. Right? Can I? Sorry, I thought it was std. std? Oh. No, it's not an std. It's a separate library. Hopefully that will work. Buffer view. Okay, so basically I need to get through the buffer view. And allocate indices. Isn't that correct? Index count. Yeah, I need to get the count from the accessor. Let's do that. Index count. index count. Is that the one? No, it's just a count. Okay, and now again, as I did here, I can take a mesh, can take indices, and I can also wait, do I have a mesh here? Oh, it's a game mesh. Game mesh, indices, reserve. What was it? Not reserve, but ensure total capacity. That was it. Ensure total capacity, index count. Okay. And then for 0 to index count, no, 0, 2, like this. I'm gonna have an index count, and yeah, I need to cast this data from the buffer. So again, we have this thing. Index data, let's call it like this. And that's going to be buffer data unpacked. But again, I'm gonna have to, because this data is also a any opaque, I'm gonna have to turn it into a U32. So align, well, if I don't know if I'm going to have to, yeah, I am going to need to align cast. Align cast to a, okay, well, basically I need to do this whole thing. I need to do this whole thing. But I'm going to instead use index count, buffer data. Oh, by the way, this might not work because they're in the same scope. Calling this, yeah, this buffer. Pointless discard. Okay. Let's just put it in a separate scope. Primitive indices. Sure total capacity. What does it say? Oh, try. Consider using try. It's funny that it says consider using try. Yeah, of course. Consider using try because you can catch it as well. Okay, and I actually don't want to cast it into a vector. I want to cast it into a U32. Hopefully. Well, here's the problem now. I don't know if this glTF type is U32 or U16. Maybe it's a U16. How long have you been using Zig? For a week. No, actually, I started with some dabbling with it like maybe a year ago. But I was just like kind of going through simple stuff, going through like those examples, and this is the first time I'm actually using it for like a real thing. This is like a week ago. Okay. So I would like to actually check what type it is. Component type. Yeah. So I need to get the component type. Index accessor component type. And this component type, I wonder if it's enum. Let's just call it index type. Let's see. Accessor component type, it's component type. Yes. Cool. Okay, cool. We have R16U. Why is it prefaced with R though? I don't know. It sounds unnecessary. Okay, so I can I can test if component type, if let's do this directly. If index accessor component type is dot R16, then I'm gonna cast the data into a U16. Okay. Otherwise, I'm gonna cast the data into a U32. So yeah, in this case, it's going to be a U32 pointer. And in this case, it's going to be a U16. So it's slightly different. That means that I need to double the doing stuff. Okay, let's make a little log here. Index component type is do enums get automatically turned into a string? I think so. I think they do. So let's just try this. Okay. So let's just do for one thing. I'm gonna just keep this nothing. Okay. Let me actually build this. Let's see what happens. Let's see what happens if it's gonna break. Okay, so what does it say? Component type is R16. I guessed so. So it's actually R16U, of course, it's unsigned. Because I think glTF automatically turns into a 16-bit if it is small enough. If it's bigger than like 65,000, then it turns into a 32-bit. I had this problem when I was working on Shakedown, so I know. You can print them with, but if you want a string, you have to use @tag name. Aha, okay. I see. The funny thing is that there's a SRC in the front of glTF. But this is enough for me. Okay, so if it's R16, I'm casting this into an R16. Let's actually output this data. Okay? And here's the thing, because this is a slice, I can just simply loop through the index data, hopefully. And I'm gonna do an I for an index, unless it's shadowed. So, or should I call it VI, like vertex index? And I'm gonna just log info it. Index. But since it's a slice, I can just append the slice. Oh, hopefully it is. Okay, let's see. Whoops. It's already active. The game is running. So there are some problems because I was running the task already. Oh, whoops. Okay, let's do this. All right. Index is... Oh, there's a lot of indices. 5085448. Okay, I'm absolutely sure that this is incorrect. So what do we do? Okay. Well, here we go. We have now a problem. Okay, maybe. Here's the thing, because buffer also comes with a stride. Maybe align cast will align to 32-bit or 64 bits. Is it going to? I don't know. That's the problem. Tag name won't include a prefix. Oh, it won't. It won't. That's nice then. Yeah, then I can do a tag name. Converts an enum into union of string literals. So yeah, this now needs to be an S. Let's just test that. Yeah, that my indices are completely wrong. I'm absolutely sure. Because this is just gibberish. Okay. So yeah, component type is R16U. So here we go. What's the problem here? Can I remove align cast? I'm not sure if I can. Let's see. Is it going to complain? Yes, cast increases pointer alignment. U16 has alignment 2. We'll panic if it's not so. You mean the string, probably. That's why. Yeah. Anyway, okay. Let's see some buffer size here. Buffer. Okay, let's go to the buffer. Why is it unknown? I hate this. Okay. Const buffer. Okay, so yes, it does have a size, and how come it doesn't C string data extras? Okay, that's actually part of the buffer view. Let's keep the buffer view here. And I'm gonna grab the buffer from the index buffer view. Okay, and the buffer view should have a size there it is. Offset size. Okay, let's log the offset. And then what else is there? There's size. Oh, it's here. Size. What else is there? And the stride. Automatically determined by accessor. I could probably like output the whole string, right? The whole struct. Okay, what does it say? What does it say? Okay, buffer view. Offset. Okay, size is 300 and stride is 0. Offset from the beginning of the buffer. Right, but I already have a pointer to the buffer. How come is stride 0? Oh, stride 0 because it's not not interleaved. Okay, so that doesn't really help me, right? It is weird. It is weird. I don't understand why the index buffer index counts data I just realized that specs guys lib is a GUI viewer. Somehow that didn't click before. What do you mean about the GUI viewer? Yeah, that's the buffer view actually doesn't help me anything. Doesn't help me at all. So the position buffer worked fine, I think, because I don't have any crazy values. But the index buffer is complete gibberish. I don't know what could be going on here. Well, the numbers I expect are like 0, 1, 3, 5, 6, 7, 8, 9, 3, 10, and stuff like that. It's definitely not this. So it's close, but it's not correct. I have a feeling this align cast is fucking it up. Maybe it doesn't allow me to read it as a pointer. That's the problem. Can I not align cast? Is it possible to like... I think it uses imgu and Vulkan to visualize GLD files. I see. How can I avoid alignment? Maybe the alignment is the problem. And that's what I feel like it is. Is there a way to view the memory in Zig somehow? Is there like don't align cast? Seems like maybe you need to start reading at index buffer view offset and size. What if I get U8? Would that mean I don't need the line cast? Because U8 is like a single byte. Oh, doesn't work. Yep, there it is. So let's see what the first value is. 166. That's a bit too high. I still have a problem. There's something incorrect with this one. If you want to unline reads, just do something like mem read int. Oh, there is that. I didn't know that exists. Read. Oh yes, of course. std mem read int. Type use 16. Bytes. Ah, I see. But you still need to cast it into a U8. So maybe this. I can take the whole thing. Index data. Endian, I have no idea. What's the endianness? Big. Okay, so what does it return? Oh, what does it say? Incorrect. Expected type const found U8. Okay, it's only a two array. Read int native. Can I just do one? Of course not. I need to give it a pointer to two array. Can I pass it the pointer? And it will return a type. A many pointer cannot cast to a single pointer. Okay, can I just take 0 to 2? But that's going to be a slice, not a pointer to a two-sized array. Oh, there it is. This actually works. So, okay, interesting. Let's see what happens here. First is 50,000. Yeah, this is incorrect as well. So there's something weird going on. 0 to 2. Oh, you just wrote it. Okay. Okay, so I think that this buffer data is bad. Index buffer view buffer. Because this is a pointer to the buffer. Well, yeah. Index buffer view. I could start reading at the index buffer, as you said. So buffer, wait, there should be data. Data dot buffers. Does a buffer view have a buffer index buffer view? Yeah, in my thing, I was just reading buffer views with the buffer view, but in this case, it is an integer. It's not. It's not. It's an index. It's not a pointer. Yeah, I am completely confused about this. Could it be a the opposite? Could it be a little endian? Is that possible? No, it's still some ridiculous number. If you need to get an array pointer with an index, you can double slice. 0 to 2 is an array pointer because start len are both comp time num. It will correspond to a slice. Interesting. If you need to get an array pointer with an index, you can double slice. Yeah, that's funny. Interesting. Interesting. Ah. Load buffers. This definitely works. Because positions seem to work, but indices are totally weird. Totally weird. Read int native, read little are both the same unless you're in a big endian Windows machine. Yeah, I doubt. I mean, who knows? Who knows how it saves the data? It's not about the machine, it's about the parser, the model saver. The exporter. Yeah, it is gibberish in any way. It is terrible. It's a terrible number. Yeah, I don't know. I don't know what's going on here. Pointer cast. I'm definitely casting a pointer into a U8. Oh, and this is not index counts. But yeah, doesn't matter. Doesn't matter in my case. This definitely is not null, because it would panic if I was doing this. And what's the count? The count is 162. Which is exactly half this. So yeah, that makes sense. Buffer view offset. Can I read the pure buffer view? The pure buffer. Let's see. It should be the data. Data buffers, no? Okay, meshes, materials, buffer views. Can I get the pure buffer? Pure buffer data. Bin. Look, there's a bin. Maybe that's the buffer. I don't understand the difference between the views and the buffers, because buffers imply that there is multiple buffers, but there is actually only one buffer. This is what I'm confused about, because if you open it in here, you can see that the data is at the end. Buffers, and there's only one buffer. Hey, look at this. This is called a URI. Why don't you try using the offset in size? Okay, well, maybe this makes sense because this is URI. But it does have some metadata here. Data application outlet stream base 64. You know what? This actually makes sense. Now I'm gonna go back to the to the original one. So buffer. This is a buffer. This is all the data in my glTF. Okay, this is what I was trying to print. Where are you from? What do you think? Okay. So URI is actually the data itself. How am I supposed to know that? I didn't know that it's actually pure data. Well, okay. So does this mean that in my other attempt, nice test cube, yeah, now I understand how to get the buffers from the other one, because URI is just a buffer. And this is a slice to a U8. And I said like, oh yeah, this can't be, this is wrong. But no, the URI is actually the data. It just needs, I need to get the offset from the buffer view. Should I just start using this one instead? Okay, let's. I don't know. I don't know. It's like I'm trying to get two of them to work at the same time. I don't know why the buffers thing is completely bonkers. And why doesn't it point into a usable data? Maybe I can look into some code that uses it. So I took this one from cglTF, which was in Jock. This is Jock. Source. It was where was it? Mesh. Zmesh. It was this one. zglTF. IO. I think it's actually in IO. Append mesh primitive. Accessor strides assert attributes. These are attributes: position, text chord, tangent. There it is. Okay. So it does say it does align cast. It's actually doing the same thing as I am. Yeah, this is for indices. Ensure total capacity, basically doing exactly the same thing. Accessor primitive indices. Buffer view, gets the buffer view. stride makes sure that it's 0. Count makes sure that it's size. Make sure that it's not null. And then it takes a pointer cast into a U8, exactly what I'm doing, but plus access or offset plus buffer view offset. Okay. Is that what I'm missing? I need to include an offset, which in my case is, what is it? It's after all this offset. It's actually, the offset is huge. Okay, maybe that's how I'm doing. That's how I'm supposed to do it. Okay, let's copy this over. So instead of this index data, we have a data address. Another resource. I think this may be doing similar. Yeah, this one also uses materials. Okay, let's go. Let me continue my process of thinking with the offsets, with the offset as well. No, this is not the correct accessor. This should be index, and then I have a buffer view. Let's try this, and this is a buffer view, which is my index buffer view. Index buffer view dot buffer is this, and then I'm getting buffer data. Okay, I can also remove this one. All right. So let's try decoding this one. First index. Okay, let's try doing the first index. Okay, let's call this one index data. And I'm gonna read int native. Read int foreign. Okay, the first index is 67. This is reasonable. I think this might be it. Index data. So in this case, I have a multi. Okay, so let's just loop through the whole thing. And this is what? This is plus. Okay, this is weird. Wait, does it have pointer arithmetic? I didn't know. I didn't know Zig has pointer arithmetic. So I guess the many pointers have pointer arithmetic. Okay, I am going to just loop through. from 0 to index data. Sorry, for index count. I see. And then it's gonna be index data. I see, but it's gonna be multiplied by 2 because it's a 16-bit. And then for each of these, I'm gonna log index data. That's the first one. Until I see by 2 plus 2. Okay, can I do this? Kind of ridiculous. Wait. Yeah, this. What is wrong? All right, index data, expected type found constitute. Okay, what if I start from here? No. Okay, let's do a slice. Is this going to work? Can you actually do arithmetic like this? Okay, it still complains. Expected type found. Why does it think that this is now? Okay. How did it work previously and not now? If I do it a pointer. Okay, so 0, 2. Okay, you're telling me to take another slice. Frankly, I don't understand the slice of slice thing. Well, there it is. It works. So yeah, I don't actually need until the end. Okay, here we go. These are all reasonable numbers. These are all reasonable numbers, and I think this is actually correct. But wait, there's too few small numbers. 3, 4, 4, 5, 5, 8, 8, 8. Like, where's 0, 1, 2, 6, 9, 6, 1, 1, 0. Okay, they exist. Is there any force? I don't see any force. Okay, there is a 4. And there's 2 4s, so that's 2 triangles. Okay, I think this is reasonable. I think this is reasonable. In 0 to 2, both start and len are comp time known. This gives you an array pointer. But why did it not work with this? That's the problem. Why do you have to do double pointering? Oh, it's because both 0 and 2 are comp time known. This is why. How do you render it? DirectX Vulkan. No, actually it's OpenGL. So yeah, 0 and 2 are comp time known. That's why. Start and end are not comp time known. I see. I got it now. Okay, so here we go. All right, let's create a mesh then. We have at least one. So yeah. This can be a lot nicer. I can feel it. But for now, let's just do it this way. I'm gonna remove this one as well. So we have indices, and now what we can do is, of course, we can push these indices into my game mesh indices. Well, here's the thing. Can I actually reinterpret an entire slice at once from a U8 to a U16? Oh, right, I can't because my indices are U32. That's the problem. Okay, so I'm gonna just append the index manually. If it is a 32-bit index, then I would be able to do it. Of course, I need to try. Okay, so here's the thing. Yeah, it shouldn't complain. So we have the mesh. We finally have the mesh somewhere, and it's not. Yeah, and it's like. Okay. We have, well, in this case, we only have one mesh, and we absolutely know that. So I'm gonna just put this mesh outside of the whole thing. Let's do that. Okay. Let's just leave calling it a game mesh, since I know I have only one mesh. Okay. And let's make an object now for this mesh. So I have engine scene, add object. My game mesh is gonna be game mesh pointer, and my material is gonna be, let's do a brick or something. Brick material. There it is. Okay, hopefully that will draw it. Hopefully. Let's see. Aha. Try. I need to try. What's the problem? Value of object ignored. Ah, yes, because I have a pointer to the... I'm returning a pointer to the object, which I don't need. And it's nowhere. It should be visible somewhere, but it's not. So we have a problem. Ah, nice. Right. The scene should be rendering. It should have an object. But for some reason it doesn't work. So what did I forget? I am adding this indices. I am adding the vertices, right? Normals are 0. Colors are 0. That's not important. UVs are also 0. And of course, since I have all the stuff, all the vectors are here. Let's quickly debug a mesh. For mesh, game mesh, vertices. Oh, this should be items. And let's do an index as well. I'm gonna do it like this, I and position. Okay. And now for game mesh indices. You know what's the problem? It's not I know what's the problem is. I don't need to output this actually. The problem is that I did not submit it. Okay, first I can defer game mesh deinit so that I don't get these errors at the bottom. These ones. No, where are these ones? Okay, but second, I need to actually create a mesh for OpenGL rendering. So it's gonna be here, create. This actually submits it for rendering. And I can only do it. Oh, this is gonna be try. Create is a terrible name though. It should be like I don't know, submit to GPU. That's I don't know what the correct name should be. Okay, let's see. Oh my god. Oh my god, it's terrible. What the hell is happening here? What the hell is happening here? Something is being drawn. Something. I think the size is actually correct. But this is completely borked. I have a feeling like one index is missing or something. So it's all offset by 1. What the hell? At least you can see something. Yeah, at least I can see something. What if I just do like -2? If my assumption is correct about being offset by 1 or something. Yeah, no. What's the value actually? Yeah, the value is completely... The value doesn't exist. The strange thing is that this shouldn't even render. So I'm not sure how this even works, because the index is a weird number. Okay, it's definitely from here. What the hell? What the hell? Okay, is there a glTF viewer that can actually output all the buffers? All the glTF viewers that I've seen don't actually give you any kind of view into a buffer. Oh, great. It's just outputting this. Choose a file. Drag a file. It doesn't really work. Oh, there it is. Yeah, but it doesn't give me any, it doesn't give me a way to go through it. Maybe I should start with a much simpler thing. Do I have a test something that is just a triangle or something? Maybe we should first draw a triangle. Let's see. I have some test files. Resource. Oh, this is HPM. glTF test. There's a glTF loader. There it is. Test cube. Test cubes. This is with different materials, if I remember correctly. Do I need to download glTF now? Blender. Let's install Blender. Watch on YouTube. No. 3.6 LTS. Nice. Just 300 megabytes. Nice. Maybe there's an online glTF triangle example. Oh, there it is. Okay, let's do this. Does it have indices? Indices, buffer views. This one doesn't have any data though inside it. Yes, because it's using an external bin. I want an embedded one. A minimal file buffer view. There it is. Okay, let's... This one does have a buffers. So let's do this. Let's do this actually. I'm gonna create... let's go back. Let's create a glTF file from scratch. Text triangle. glTF. There we go. It doesn't have glTF. Okay, maybe there is extension. glTF model viewer. Yeah, let's try this one. glTF tools. It doesn't give me any recognition. Triangle glTF, but it does have a preview. Error installing glTF tool establishment. Okay, it doesn't work. Who cares? Okay, hopefully this works. Let's load from glTF. Let's load that one. So it's gonna be a triangle. Let's see. I don't see anything, but okay. Here we go. The indices are correct. 0, 1, 2. The vectors are, this is basically 0, 0, 0, 0, 1, 0, 0, 1, 0. This is correct. Wait, why is it 0, 1, 0? And this is also 0, 1, 0. Okay, there's something weird there. But it does have 3 vertices, which is correct. But that's because I'm looping through the vertex count. Is this align cast working correctly? Maybe again I should do it like this with the vertex data. Maybe that's the problem. Let's just use this example from Jock again. Where was that? This one. Okay, let's see what it does for attributes. Yeah, it uses the offset also. Okay, let's try that. Instead of my custom way to do it. Data pointer. This is buffer data. But do I need to unpack it or not? Buffer data. Buffer data. How come I didn't unpack it here? And here I'm unpacking it. That's strange. How come it's an optional here and here it's not? Maybe because I'm casting the data directly. It would be fun if this was the issue, because the optional starts a little bit earlier. Perhaps. Any differences here? Oh, I need to shut this down. Is it going to run again? No. Let's do it again. No, that doesn't change anything. But I don't need to unpack the optional, which is strange. Okay, so let's do this. Plus buffer view is... Okay, I didn't put in the buffer view. So instead of this, let's grab a vector through the same way I did this. So std mem read, but there's no read float. Wait, how does it do it? How do they do it? In Jock. Okay, it just compiles into cast a slice. Optional pointer doesn't start earlier. If you cast without unwrapping the pointer, you would get a runtime panic if it's null. I see. To read a float, you would read a U32 and bitcast to F32. So yeah, this one again. Oh, this one does the same thing as I did. But yeah, it casts into different depending on the attribute, which can be outside. So let's see. Vertex count. Okay, so this turns a slice if there is no for loops. This is just directly doing it as a slice. Okay, let's just temporarily hide this, because this might actually be correct. Okay, so this is gonna be a slice of vertex counts. And then what? And then append slice. But yeah, I need to actually get the vertex. Does it actually pack all the vertices into a... It's not interleaving the vertex data, the attributes, right? It's actually has them all packed into a single... all the positions in one line, and then normals, and then one. Probably. Oh, this one is still running. So yeah, I need to run through all the slice for slice vertex. I can also, I don't need to do a 3 thing vector. Right? I can do a pointer. I can do a pointer to a... maybe this is this is maybe aligned to 4. Because this is a SIMD vector. Maybe that's the problem. This is aligning to 4 instead of 3. I didn't think about that. Yeah, this is also the reason why I can't pack a vector. All right, I think I just realized something unrelated. I think I just realized something completely unrelated. Let's actually try this. Let's try instead of instead of this. I'm gonna continue with my vert data. I'm instead gonna cast into, instead of a vector 3, I'm gonna cast into a 3, as I did here, as they did 3, but it's const. I don't know why it's const. I guess it can be const. And then I'm gonna, I say that this is vector, but actually I'm going to convert it into a vector. Is it possible to convert the vector with this? Vector of f32, 3. Yeah, I'm gonna just make a new one like this. Will this work? I hope so. Expected type. Found type. Okay, so maybe it's the other way. Yeah. Yeah, the length is first. Okay, let's see. Does this work? There it is. They're completely different now. We have a 0, 0, 0. We have a 0, 0, 0 basically. And then we have a 0, 0, 1 and then 0, 0, 0. Okay, why is there 2 of them at 0? This is suspicious. But let's try to not use a triangle, but let's do a test cube now. Already active. It's not active anymore. Terminate. Hey, hey, hey. Hello there. We have a cube. We have our test cube. Oh my god, it works. It's not correctly rendering. It's only rendering the back faces. But hey, we have something. Look at that. It's beautiful. It's majestic. Okay. Yes. Oh, by the way, I didn't see that. Yeah, so I didn't understand. This is something unrelated I realized. Is that you can't really cast to a vector because vectors will always align with SIMD registers, with the width of SIMD registers, right? So they will always be 4-sized. This is why you can't actually pack vectors. This is really interesting. This is why the size of my vertex is... This is what I was trying to explain. Okay, and now I understand why. Now I understand why. Where's Excalibur? There it is. There is Excalibur. I was trying to explain here that my vertex, for some reason, is like 16 bits long. Each component is like, sorry, bytes. It's 16 bytes. And I wasn't sure why. I was expecting this layout. And it turns out that it's because I'm using Mach vectors. And Mach vectors actually use backing vectors. And I think because they always align to the highest, like to the whole thing, to the register. Because okay, let me try to do something. Let's see if this is gonna work. Test struct is struct, and I'm gonna add a vector. This is gonna be vector 3. Let's do of F32s. Vec2, a vector of 2 F32s, and now I'm gonna pack them. And let's see. Is it gonna tell me that it can't pack them? Doesn't say anything. Okay, so they are packable. Are they packable? How can I do this? Size of... Okay, let's do compile error. Compile error... compile error... size of... This is how you do it correctly. Maybe I need to do this. Let's see. Give me a compile error, please. Okay, compile error is... What is a compile error? Unreachable code. Come on. Come on, don't give me a compile error here. Unreachable code. It's complaining about unreachable code. Okay, let's see. I have to run it at the end. God damn it. Expected indexable font content int. Indexable. Okay, how do I turn this into a string? This is too complicated. I could have just used the log info. Yeah, you know, in it would be nice because okay, size. Let's try this. It does say unknown. Yeah, this would be cool because in C++ you can actually do a size of and just hover it over it and it will tell you what size of it is. That's something that I would like from actually from ZLS. I'd like to be able to hover over a struct and just see the size of it, because that's something that I very often need, and then I need to do this. Compile log. Compile log. Okay, that's... Didn't even knew that was... Oh, wait, it's actually a variable function. Can I do this? Can I do this here? Is it actually going to be formatted or not? Found compile statement, log statement. Is this the way you use it? I don't know. I'm just shooting in the dark here. Okay. Let's do this. Okay, what does it say? Struct size is 24. 24. So 3 by 4. 3 by 4 plus... Oh wait, what the hell? 3 by 4. 4 plus 2 by 4. What? Wait a minute. 3 by 4 is 12. 2 by 4 is 8. That's 20. It's actually 24. Okay, that's strange. What the hell? How is this possible? Compile log also show 24, but it always errors during compile. Oh, did it actually show? I didn't see this. Did it work? Then I didn't see the error. I was looking too much at the error. But where? Where does it say 24? Ah, there it is. Compile log output. Oh, I kept looking into this. So yeah, why the hell is this spec struct 24 sized? It makes no sense. Okay, if I don't have it packed, what's the compile log then? It's 32, you see. So it takes 16 plus 16. Yeah, if you don't pack it, it will align it. But how come I couldn't align... I couldn't pack a math vec 3. That's actually vec 3 in... Oh. Math vec 3 couldn't be packed. Or could it? Compile log 32. Yes, that makes sense. And if I try to pack it... There it is. Only packed struct layouts are aligned in packed types. Struct declare. Ah, it's because it's an extern struct. Is that why? Is that why I can't pack it? That's quite likely. Are allowed in packed types. So packed types. I guess it's not allowed because it's an extern. Well, it still stores a vector. Yeah. 24 bytes, 12 for each. So even if it's a vector 2, it is using 12 bytes at the minimum. That's strange. Like this one. Let me check again if I didn't get something wrong. Yeah, 24. Yeah, strange. I don't know. And yeah, for that reason I couldn't pack vertices. Okay, so this works. This works. I need to convert it into a vector 3 later. So that was the problem. That was the problem. The align, the cast had to be in 3s. But then what is this accessor offset and buffer u offset? Maybe I'll need this when I decode other stuff, not just positions. You know. Okay, since we have the it working now. Okay, let me commit this. I'll have a triangle, although it's not working. It's not visible. It's probably facing the other way. That's the problem. Okay. Well, let's say what I've completed. It's pi time. 3:14 a.m. Okay. Load a mesh with vertices and indices. Done. Load multiple objects. Not done at all. I'm just glad I got this working. Okay, I'm just glad it works. Okay, this is my engine, my old engine. Okay, so let me just fork this. Stream. Okay, working. Loading glTF model now works, but only from only positions and indices. Now works. Cool. Okay, now that I have positions, I should decode normals. Extern structs can actually pack smaller than pack structs if you specify align 1 on each field. Then I don't know what the problem is. Why vector 3, Mach's vec 3 is not packable? Okay, so I'm guessing that this thing is going to work with positions but may not work with normals. Let's try. So the attribute, this is where we start with the attribute. But I can move a lot of things outside, like the vertex count, the vertices as well. I think that this all can be moved outside. Because for each attribute, okay, if I try to ensure a total capacity, invalidates pointers if additional memory is needed. Can I actually call this multiple times? And yeah, I just discovered through this thing that I don't need to do where is jock? There it is. I don't need to convert, attribute type. There is an attribute type. I don't need to compare strings. So I can just say attribute type is position. Equals. And I don't need the name. I'll keep it for later, but not. Let's see if this works. Probably because Mach doesn't specify line 1 on the fields. Probably. There it is. It works. Okay. Let's submit that. No longer necessary to compare names. Okay, let's actually push this so we can play around. Okay. Accessor attribute data vertex count. So I get the vertex count from the accessor. Attribute data. Attribute data accessor. Strange way to call the accessor. Okay. So anything else? Buffer view. Okay, this is specifically for this attribute. No. So it would be nice to actually get the vertex count over here, because attributes are not going to have different. Okay, let's do something like this. I don't have the attribute, but primitive attributes. I can just take this first one and hope for the best. And then I get data dot count. And let's call this a vertex count. Everything, by the way, is going to be const, because nothing is changing. It's all just reading data. So I'm going to turn everything into const in the end. And yeah, I need to make sure that attributes len is more than 0. just in case. Okay, so I ensure total capacity here. And then I don't need to do any of this. I don't need to get the vertex data, the vertex count. And I don't need to ensure. Okay. So that's the accessor. Buffer is also part of everything outside. And the buffer view, which I don't actually use in this case. I use it in the other method, which I've commented. So yeah, the buffer is outside. But yeah, let's actually use the buffer view just so that I have a little bit cleaner way. And if it errors, it will error on this line instead of this line. And then I will be like, well, is the buffer view null or is it the buffer problem? So yeah, maybe I can get the buffer view here and then I'm gonna use buffer view buffer to get the buffer. And let's make everything const. Okay, so that's the whole thing. Let's do else if attribute type is normal. Right? Well, it doesn't say anything. Okay, if it's a normal, I'm still going to unpack this as F32. And then for each, basically do the same thing. But instead of normal, I'm doing normal here. Let's see if it is dot normal. Okay. And by the way, this should be append. I shouldn't append it. Instead, I should set the normal. I should set it instead of appending. But I don't know which one comes first. Is the position going to come first or normal? So whichever comes first, I need to append. Yeah. I could append a slice at the beginning with the size of with an empty ones. Can you actually do something like this? Vertices append n times. And the value is gonna be nothing. And the size, okay, I'm gonna do this outside. And I'm gonna have the size of vertex count. So now, and of course I need to try, right? Append times. Allocates more memory as necessary, invalidates pointers. The function is in line, so that the comp time no value parameter will be. And I have a feeling like I don't need ensure total capacity then. Okay. What's the problem here? Does not support field access. attributes. And it doesn't have a len. It doesn't have a length. Okay, attributes count. That's the one I need. Maybe I was wrong above. 24 seems to be the minimum size. Aha. Okay. I see. Maybe it is. Okay, let's get this done. Okay, assert append end times. Okay, so instead of appending these, I'm actually going to change vertices, items, vertices vi dot position is this. And I'm going to not log anymore. Okay, and then I can do the same thing for this, except that it's a normal. Not normal. Let's see if this works. Let's see if the buffer is actually... Yeah, I wonder if the accessor buffer view is different. Is different for position and for normal. Or is it going to be the same one? No field named attributes. In what? Wait a minute. And what is this? What is this then? Primitive attributes. Oh, attributes. Okay, yeah, no attributes, please. Only attributes. Here we go, but it doesn't seem to be working with the normals. Or maybe it does, it's just the upside down. It's possible that it's just upside down. Or maybe it's totally wrong. Let's actually output the normals. After all, I do want to output the normals. Oh yeah, it's still running. Yeah, these are too big of a numbers. This is not a normal. This is not normal. -1. Oh, but at least this is terribly formatted. Let's do better formatting. I think it goes like D.2 or something like that. Yeah, this is more than 1. This is just wrong. This is just wrong. This is not normalized. I think this is exactly the same as position. So maybe after all I do need the offset. Let's see if this is the same as position. Yeah, minus 0.3. Oh, I should say and I'm gonna do tag name, attribute type. Start of attribute normal. Minus 0.3, minus 0.5, minus, 0.3. Yep, this is minus 0.3, 0.5, 0.3. Yep, this actually explains that this is the same as position. So my estimation is incorrect. Yeah, I definitely need to add the stride thing as I did here. Vert data v should work, I think. You think so? Okay, it does work. Cool. I didn't know you can cast three a float into a vector. How does this even work? I'm just grabbing the first value. This is strange. Like, why does this even work? I'm not sure. Vectors and array scores. Okay. But you still need to point into the first item. All right. So apparently I don't need this then. Can I output the array? No. Yeah. Okay. I'm just gonna cast it. Vert data I is a 3. Oh, right, it is. I didn't think about this. Yeah, because this is actually a slice of all of them. Right. So I can just do this. Can I? Let me also not log indices and also not do this afterwards. Okay. So yeah, there it is. It is a vector. It is an array. Okay, so let's grab a slice in this way. Okay, let's say that what did I make? What kind of changes did I make? Attempting to render normals. To assign normals. Okay, so the only thing... Oh, this is the wrong one. I was looking at the wrong one. Okay, so let's actually take this one with an offset, and this can be outside as well. So we have buffer data plus these two. Let's put them in the same line. As a U8 again. But they're all actually F32s. Right. But I am actually changing the data address later. Okay. So I am going to take this one. And turn it into basically the same thing with data address in here, and yeah, so basically I get a slice of the address, and in this case the accessor of my attribute is going to have a different offset. That makes sense. That almost makes sense. Let me check if this is the same. Const, okay, const f3, f23, 32, and then vertex count. Okay, I could have just copied over the entire code, but that's fine. I'm discovering it myself. I'm discovering it myself. Okay, we have. Do we have different normals? No, they're still the same, because I'm still reading the same thing. over there. So let's put this now in here. It's a data address, and there it is. Okay, this hopefully will give me some normals to work with. All right, I think this works, except that it's a flipped around cube. I don't know why exactly. And it's also pointing in the wrong direction, I think. Test cube. So the red should be right. I think it's flipped around. It is flipped around because this cube thing should be in front. There's something wrong with the winding, or yeah, strange. I can always flip the X around, but should I do this? Am I doing some kind of flipping here? I am doing the UV flipping. But I shouldn't use the same thing for my position. Okay, so that's cool. Normals work. But it's flipped around. I'm now wondering if something else is flipped, maybe a camera matrix or something. Okay, let's clean up. I don't need this. I don't need found position. And I can remove all this. The only relevant thing is this. I don't even need to log it. Unless I really want to. And I can also remove yeah, that's about it. And then I can also let's do text coordinates. Text coord should be 0. Attribute type. Let's find attributes in this one. Attribute. Okay. Attribute type. Position, normal, tangent, text coord. Let's go with text coord. Dot type is dot text coord. And then, in this case, the type is 2 F32s. And then I also loop through and assign it to oh wait, I don't need to do this vert data now. I don't need to do the vec conversion because vert data is there already. And instead of this, I say UV is vert data VI. All right. And that is not going to be visible anyway, so okay, and then anything else I can assign color as well. And color is going to be 4 component. But I can only assign a 3 component. It doesn't matter. The color is not rendered anyway. Anyway. So we have now positions, normals, text coordinates. So why is my position why is my everything inverted? That's the question I'm asking myself. You know, I could actually create a vertex with like flipped around Z, maybe like this. 0, 1, 2. Compilation error. Expected equals. That's the problem, right? Okay, here we go. We have correct. Oh, look! It even has UI coordinates, but it's actually rendering a wrong texture because I'm not loading the texture. Cool. So it has correct orientation now that I've flipped the minus. But I shouldn't do this. This is why I'm concerned that maybe something else is flipped, like the camera. The perspective matrix of the camera or something. And by the way, the light comes from the front, not from the back. So I need to flip. I need to flip this one as well. Well, I wish I could have a lambda now, but Zig doesn't have lambdas. I'm gonna have to add a new function. Flip Z. That's gonna be a 3 components vector Okay, so they don't have to write it. I can just say flip z vert data vi. Okay, there we go. Now hopefully the sun is going to be on our side. There it is. With flipped Z. We have a model as well. The only thing I'm not loading now is the texture, which is embedded in the file. I think I'm gonna end here. We have texture render. We have model loading. Finally working. There is actually a lot of things to support now because I only have one mesh. I need to have multiple meshes. I need to have support for, you know, it's realizing which meshes it's. Yeah, what I've done is only mesh loading, which is just this part. And now I have, yeah, so it's just this part. And now I have the rest to implement, like materials, textures. How am I actually loading a texture? I wonder. Textures. Oh, I even collapsed this one. So yeah, images. Right, there are images. And then I load. Aha, I have the bits. A buffer copy. Interesting. I'm malloking this. Unsigned char. Create texture. And then I'm directly creating a texture. Good progress. Yeah, good progress. I thought it would be much faster though. Okay, let's record this. Now with UVs 2. Now with UVs from glTF 2 and cleanup. Okay, I'm going to submit this. Going to push this. Data. Okay, so this is going to be meshes. I need images. Okay. So I think this is the problem of ZLS. I think it doesn't know how to capture exactly. Images count. Yeah, it's totally confused about this image. Okay, let's see what the image is. Name Yuri buffer view. Yeah, basically I just need to decode now the buffer. So images, I get the image. Where is, oh, I can get the height and the width as well. So, copy the image buffer so that it stays alive for the whole runtime. Okay. I guess I'm going to have to allocate that. You can blame me and chat for slowing you down. No, it's okay. Can I? Okay, let's see if I can quickly load these images. At least one image, at least. Copy the image buffer so that it stays alive. Okay. Buffer. But where is the buffer? Image. Image at. Image.image. Okay, so this one has an image, but no, this one has a buffer. Strange thing is this one doesn't provide any texture. What? Okay, what's the difference between a texture and an image? Now I'm confused. But it doesn't provide any info on it. Texture view. There's a texture view as well. Oh, texture transform. All right. This is far more difficult than I thought. Has Basisu. Yeah, there's no width or height. That's strange. Okay, let's look at Jock. Does it actually load? Does it load append mesh primitive? Does it load images? I don't think it does. Maybe this one doesn't even support images. Texture. Oh! I see. So a texture. I should actually loop through textures, not images. All right. for each texture source is more than -1. And I have a very nice comment that says why. I think I probably copied that from some tutorial, and I was also wondering why. Imports has an invalid texture source. Okay, let's do the same thing. Texture source. Textures. There is no source in a texture. Great. Maybe the source is the image. Yes. So I think this actually links directly to the image. Okay, and then this image contains the size. But it doesn't have a size here. MIME type, extras, extension count. It only has a buffer view. What does the texture have? Does texture have any image sampler? This one doesn't have. Okay, what's the texture transform then? Let's see in my text cube. Images. So image MIME type PNG name test cube. Okay. Nodes. Test cube default. Materials. Material has a base color texture at 0. And source is 0. I think that source is the image. Okay, so texture points to the source, which is the image. And then I have the buffer view 4. So then I scroll to buffer view. Buffer view 4 is 0, 1, 2, 3, 4. It's the last thing. And it has a byte length and a byte offset. So I'm assuming that I should grab a buffer view of the image. But it's actually a texture view. Maybe I should get the texture view instead. So you get texture views from materials, apparently. Texture transform. Okay, I think it's actually the texture view that I need and not images and textures. Yeah, but I need to loop through all the materials for that. So it's the other way around. Actually, first, I need to go through materials. Because in my C++ code, what I did is I actually first had materials. Find which textures belong to which materials. Yeah, because I had to go through the materials and find how to link textures to materials. But here I need to loop through materials first. I think so. To be able to get the texture views. Material is not texture view. What's material has material roughness. Which one is it? It's called something like base. Yeah, it's actually in PBR metallic roughness. And then dot texture view, I guess. No, it's base. PBR metallic roughness base color texture. Dot. Okay, so this is the texture view. Okay, that's this build. There is a problem. Data images. Okay, I'm not gonna loop through the images. Okay, that worked. So I need to grab the base color texture. And that will give me a texture view into the texture. Yeah, but still, I know nothing about the texture itself. Again, where is the data of the texture? Texture view does nothing to me. Text coordinates. Okay, I know which one. Scale. Transform. It has offset. Oh, that's the size, I think. Texture transform. Or maybe this is the UV offset. I have no idea. I think this is actually the UV offset. I don't understand how the images don't provide you with the size. That's really strange. Okay, I am going to continue some other time. I don't know if that's going to be tomorrow. I am not sure. Because I'm pretty busy tomorrow. But yeah, thanks for joining again. There's no width here anywhere. Nothing. So the C++ glTF has width and everything. You can load textures. There it is. It gives you width and everything. Super strange that it doesn't have that. Okay. So, thanks for joining again. I managed to draw a cube, a test cube, although not with the correct material. But it's a start. It's a start. I've decoded the vertices, normals. I could now draw basically anything. Hopefully in a while. Yeah. Good progress. Good progress. It's not bad for a completely new engine. It's not been even a week, right? I don't know. When did I actually start? Last Friday? Did I start last Friday? Or was it Saturday or something? Maybe it's a week. No. So yeah, not bad progress. I was expecting to finish this glTF much sooner, but too many things, too many bytes to decode. Yeah, it will be much nicer to have a much better interface. Maybe I will look into that other library that you suggested. What is the other library thing? Specs guide glTF. Okay, I'll take a look at that. Okay. So yeah. Nice. Really good progress. So, what have I done so far here for the stream? Load multiple objects? No, but vertices and indices. Load normals and colors. No, I am loading normals. So, yeah. That works. Oh, normals and UVs. That's the ones. I am loading normals and UVs. That's correct. Okay, and then I need to do a test with multiple objects, multiple textures. But I first need to actually abstract that in the abstract asset manager. But of course, first I need to decode load textures. Load a texture at first. And then I will know how to wrap it around in the asset manager. So yeah, that's going to be for the next stream. So, stream number 10. There we go. It's ready. glTF. Okay. Cool. Yeah, see you next time. Thanks for joining. It was a nice journey. This is not the engine. This is just the Microsoft 3D viewer, unfortunately. Yeah. But this is the engine, and this is the mesh inside it. Cool. Okay, until next time. See you.